Assalamualaikum and greetings to everyone. Welcome to my final year project presentation. I am Aina Nadirah binti Nur Arfendi, a final year student in Bachelor of Science, Honours, Chemistry with Management. The title of my final year project is Synthesis of Retronecine Intermediate 3-pentan-NO heterobicyclic butyryl lactone. I am supervised by Prof. Madya Dr. Muhammad Tajuddin Muhammad Ali. This is an overview regarding my presentation that I will talking about. First, let's begin with introduction, which consists of background of study, problem statement, objective of study, and significance of study. Pyrrolizidine alkaloids are type of secondary metabolites in plants which composed by nascent bases and esterified with nascic acid. One of the most common nascent bases is retronecine. The first synthesis of retronecine was conducted by Gaisman in 1962, which was synthesized from Gaisman waste lactone through Gaisman lactonization in 12 steps. Retronecine have a variety of biological activities such as hepatotoxicity and anti-cancer. For problem statement, there are several studies that were conducted on synthesis of retronecine intermediate. However, they use the route that developed by Gaisman, which the route is too long and only produce a low yield percentage of product, which is only 0.91%. The goal of these studies is to synthesize retronecine intermediate 3-pentan-NO heterobicyclic butyryl lactone as well as to characterize and analyze the product obtained by using a spectroscopy technique such as NMR, IR, and mass spectroscopy. The significance of this study is to synthesize retronecine intermediate with a new approach and shorter route, and also develop novel molecule structure for the synthesis of retronecine base, which can further form as a novel pharmacological agent. Moving on to the literature review. There are several studies of retronecine intermediate, and the most recent one was proposed by Joshua Chris Smith in 2016. He was successful synthesis retronecine with only 8 steps, which shorter compared to the synthetic route that developed by Gaisman. Another synthetic route that successfully published was proposed by Huang and co-workers in 2004. They successfully obtained the retronecine with high percentage of yield, which 63% yield of product. These are the mechanism synthesis of retronecine which proposed by Huang and co-worker and also Joshua respectively. The results obtained in this study will be analyzed by instrument spectroscopy, which are NMR spectroscopy, IR spectroscopy, and mass spectroscopy. The synthetic route below is the route that I use in this project. First, compound 6 will undergo allylic oxidation reaction followed with esterification reaction, and the last reaction is lactonization reaction. For allylic oxidation reaction, the chemical used are dry ethanol, selenium dioxide, and 3-butyl hydroxyl peroxide. The reaction was stirred for overnight under inert atmosphere. The second reaction is esterification reaction. The chemical used for this reaction are dry ethanol or 3-pentanol and boron trifluoride etheride. Same as allylic oxidation reaction, the mixture was stirred for 24 hours under inert atmosphere. The last one is lactonization reaction. The solvent used for this reaction was biphasic solution, and ruthenium chloride trihydride was added followed with sodium periodate. The reaction was also take under inert atmosphere and was stirred for 24 hours. The figures showing the process after performing the reaction. First, for the first figure, after the reaction, the mixture was extracted with sodium hydrogen carbonate and followed with brine. Then, the mixture was dried over with magnesium sulfate. Next, The mixture will evaporate under reduced pressure to give crude product. And the last figure is the example of thin layer chromatography that was done after column chromatography. I start with first reaction with allylic oxidation reaction. In this reaction, dry ethanol was used as a solvent and selenium dioxide was added to serve as a selective allylic oxidant agent. From the table, the 1H-NMR spectrum shows the presence of two protons that bonded to an alkene group which resonate as a multiplet at 5.66 to 5.75. These protons are the most shielded because they are directly attached to the carbon-carbon bond that has anisotropy effect. Next, the proton of methyl group appear in the most shielded region as a singlet at chemical shift 1.40. There are two types of solvent were used, which are dry ethanol and tripentanol, which produce two different products. The presence of boron trifluoride etherite, which will act as a Lewis acid catalyst. The table shows the 1H-NMR result for esterification reaction. Beside proton that attach to the carbon-carbon double bond, proton who attach to the nitrogen also appear at the downfield region as nitrogen is an electronegative atom. This is the result for mass spectroscopy. For allylic oxidation reaction, the molecular weight calculated was 229. From the mass spectroscopy, the molecular weight was shown 229.1, which is the exact mass of the compound. Next, for the esterification reaction, the molecular weight calculated for compound 8A is 257.33. From the MZ value, the molecular weight was shown 281, which is the weight of metal, 1 sodium and 1 hydrogen. And the last, for compound 8B, the molecular weight calculated it was 299.21. From the mass spectroscopy, the molecular weight shown at 324.90, which is the weight of the metal with addition of 1 sodium and 2 hydrogen. Next, for infrared spectroscopy interpretation, we can see that all the important functional group has been analyzed. The hydroxyl group with a broad peak will appear in the range between 3000 to 3700. Lastly, for lactonization reaction, this is the mechanism of this reaction. Ruthenium chloride trihydride will cleave the double bond of compound 8 to produce decarboxylic acid, which then the lactonization occur to form a 5-member ring of derivative lactone-lactam. However, compound 9 was unsuccessful to synthesis in this project. The synthesis of compound 9 has been done few times, however the result obtained was inconsistent. This happened due to the limited starting material, which is compound 8, and lack of time also one of the reasons why this synthesis failed. In conclusion, the last product, 3-pentan-NO heterobicyclic butyrylactone, which is the intermediate of retronecine, had been unsuccessful to be synthesized. The limitation of starting materials is one of the reasons why the target molecule was not obtained. However, the derivative of butyrylactone, which are compound 8A and compound 8B, were successful synthesis in this project. The percentage yield of compound 8A and compound 8B that I obtained are 39% and 43% respectively. The molecular structure and functional group of this compound had been successfully analyzed by NMR spectra, IR spectra, and mass spectroscopy. For improvement, we need to use the suitable solvent and desirable condition when performing this reaction. We need to make sure that chemicals that we use are uncontaminated. This is because the purity of chemical is crucial when performing the reaction. contaminated will affect the accuracy of the product obtained. These are some references that I use when do this project. That's all from me. Thank you for your time.